We've seen that according to functionalist theories of mind, mental states are just functional states, and just as a functional state can be realized in a brain, a functional state could also be realized in a machine, a computer, an AI system. We have some selections from an influential article by John Searle. This is the article in which he first laid out the Chinese room thought experiment, which has since generated a lot of debate in philosophy of mind. He lays out his reasons for skepticism about the premise that computers can think. This is a rather sharp criticism of functionalist theories of mind, and that's his main purpose in this article, is to show a number of reasons why he thinks functionalist theories of mind are profoundly wrong-headed, just way off. So his purpose in this article is not to lay out his own view, but to criticize functionalist theories of mind on a number of grounds. It's a little bit hard to say where his own view would fit on the spectrum of views as I've laid it out. In any case, that's not his purpose in this article, so we won't worry about that. Bonjour and Baker say in their introduction that his view is a version of materialism, but it's hard to see where exactly that would put him on the spectrum, since obviously he sharply rejects functionalism. That would seem to leave identity theory, but he never says that either, and an awful lot of what he says seems actually closer to an epiphenomenalist view, and I'm basing that not just on this article but on books of his that I've read, where it seems at times like the view he's describing would be closer to epiphenomenalism. He doesn't say, he oftentimes says in this selection that we have, that brain processes cause mental states, but he never says that the two are to be identified like J.J.C. Smart would say, as we've seen. But in any case, it's not important for our purposes at the moment that we pinpoint in kind of any precise way where his own view fits on the spectrum of views. The main purpose of this article is to get across his reasons for rejecting functionalism. And he thinks functionalism rests on a number of simply profound misunderstandings. In the selections that we have, he asks, could a machine think just by virtue of implementing a computer program? In so many words, that's what the functionalist is saying. Mental states of the kind that are associated with the human brain are really just a kind of program that is made possible by the physical processes, the neurophysiological processes, the biochemical processes going on in the brain. And just as here again, a brain can give rise to those processes, a computer program is structurally the same. It's just a structurally, here again, isomorphic phenomenon based on a different kind of hardware, based on silicon chips rather than gray matter. But in principle, no different. Here again, in both cases, the program, so to speak, coordinates inputs and outputs. So I've given examples of this in the last lecture. Again, in the case of a simple computer like a Turing machine, the input would be the symbol on the tape, and the output would be some overt physical behavior. And we've talked about examples of how that would work for the case of the mind and the brain in the same way, or for human mental states. But as we've seen, the functionalist thinks that there's no profound difference between the two cases. It's the same phenomenon, just being realized in different physical arrangements, just being realized in different hardware, so to speak, either the gray matter and synapses and neurons and so forth of the human brain, or in the hardware of silicon chips and all of the other hardware that goes into computers, computational machinery, artificial intelligence systems. Searle does not believe that computers are thinking, and he's skeptical that they ever will. He doesn't go so far in this article as to say that he knows with certainty that no machine could ever think, but he expresses considerable skepticism about it here. As a kind of stylist, as a philosophical writer, he's very similar to Hume in that he doesn't really spend a lot of time, as I said a moment ago, laying out his own view. He spends his style is more negative, kind of tearing down what he takes to be false beliefs. And at the time that he presented this article in Scientific American magazine in 1990, functionalism was kind of becoming a big deal, and in a way that's kind of similar to what we saw in Hume. He's one of those philosophers that kind of looks at the main trends of philosophy in his own time, and challenges them. So we have a number of reasons for thinking, or at least for being skeptical that a machine ever could think, according to Searle. He distinguishes two different versions of AI, and what he's criticizing is what he calls strong AI. Strong AI would be the thesis, again, a strong artificial intelligence thesis would be the thesis that thinking is merely the manipulation of formal symbols. And we did see that in our selection from Turing. Turing and contemporary proponents of functionalism like Voter believe that that's all that thinking is. It's just the manipulation of formal symbols. And once the symbols are connected to behavior, connected to outputs, then mental states are just the internal states of the entity that here again either is a computer, or maybe in the case of a more complicated kind of artificial intelligence system has a computer as its brain, so to speak, or here again in the case of a human being that has a brain. The hardware running the manipulation of symbols and coordinating the manipulation of symbols with behavior, that whole phenomenon gives rise to these internal states, what we call mental states, in virtue of which the thing can coordinate inputs and outputs. So that, as we've seen, is the that is the functionalist view. What Searle here is calling strong AI, thinking is simply the manipulation of formal symbols. That's all that mental states are. They're just the internal processes that go on when something with a mind, whether a human being or a computer, is coordinating inputs and outputs in virtue of its internal states. And Searle says that proponents of strong AI, proponents of this strong artificial intelligence thesis, believe that by designing the right programs with the right inputs and outputs, they are literally creating minds. So that was certainly Turing's view. Turing's view was that even the relatively simple computers of his own time were already entities that had minds. And then more cautious proponents of functionalism would say, well, maybe we haven't created minds yet, but as artificial intelligence advances, at some point it's plausible that a sufficiently powerful and sophisticated AI system will give rise to mental states. So proponents of functionalism fall along a spectrum of views with respect to that question. Are we already there, or how close are we? But in any case, Searle is right that they do believe that they are creating minds. And he distinguishes strong AI from what he calls weak AI, the thesis that computer models are useful for studying the mind. And he says that's fine. He has no disagreement with that. But a computer simulation of what happens in the mind is only a simulation. It's only something that mimics what the brain does. And as we'll see him say a little bit later, simulation is not duplication. A computer model that simulates what happens in the mind will never have the causal powers to produce mental states that the human brain has, according to Searle. So he lays out the Chinese room thought experiment, And in the scenario, there's a man in a room, and he doesn't know any Chinese. But there's an input slot and an output slot. And through the input slot, pieces of paper with Chinese characters are come in. And he has a rule ledger. He has a system of rules for matching one string of characters with another string of characters. So when presented with one string of characters as input, man in Chinese room consults the computer table, consults the rule ledger, finds that sequence of symbols. Again, man in the Chinese room is just matching the symbols in the rule ledger with the symbols that come in through the input slot. He's just matching those characters on the basis of their shape. The characters don't mean anything to him. They're just different shapes. And so he matches them on the basis of their shapes, and then in the computer table, in the rule ledger, there's a set of instructions when presented with this sequence of this sequence of shapes as input, output this sequence of shapes. So he reaches into a basket that has slips of paper with strings of Chinese characters, and he matches the sequence of symbols to be outputted in the rule ledger or the computer table, the set of instructions. He matches that with some sheet of paper with Chinese characters on it in the basket, and then when he finds that, he outputs those characters. So of course this whole arrangement could be set up in such a way as to mimic Chinese speech. And somebody standing outside of the Chinese room, and here again, the Chinese room is really an analogy for what goes on inside a computer. To the person outside the Chinese room, if the rules are set up in the right way, if the set of instructions in the rule ledger is devised in the right way, then it will appear to the person outside the Chinese room that the Chinese room or the man inside the Chinese room, whatever is going on inside the Chinese room, knows Chinese. Because the outputs will match as a kind of verbal response in the Chinese language what a speaker would say. But the man in the Chinese room doesn't know any Chinese. He's just matching the symbols on the basis of their shape. So we said Searle, we saw Searle a moment ago say, well, we saw him ask, could a machine think just by virtue of implementing a computer program? Well, in the implementation of a computer program, Searle says, that's all that's going on. What happens inside a computer is just kind of manipulation of formal symbols. And what is meant by formal here is to say that the symbols are just being matched on the basis of their shape. That's all that a computer is doing. It's just manipulating symbols on the basis of their formal properties, on the basis of their shape. And of course, if the programmer writes the rules in the right way, that matching of symbols can mimic speech, will appear to imitate speech. It appears to the person outside of the computer, so to speak, and by way of analogy, it appears to the person outside of the Chinese room that the computer can speak, or that the computer knows a language. But Searle's point is that just as man in the Chinese room here again doesn't know any Chinese, a computer doesn't know any language. A computer here again manipulates symbols in such a way as to mimic knowledge of a language, to mimic conversation, to mimic language use. But that's not what's going on. It's just a simulation. The symbols don't mean anything to the computer, just as the symbols don't mean anything to the man in the Chinese room. So Searle thinks functionalist theories of mind rest on a profound misunderstanding of what goes on in thinking. Thinking is not simply the manipulation of symbols on the basis of their shape. The symbols mean something to the person who understands a language. And Searle's point of view is that symbols don't mean anything to computers. The point of the thought experiment, Searle says, is this. If I do not understand Chinese solely on the basis of running a computer program for understanding Chinese, then neither does any other digital computer solely on that basis. So here again, that is what we saw Turing say in so many words. Simply in virtue of running a program, simply in virtue of implementing a program, the Turing machine is thinking. Simply in virtue of coordinating inputs with outputs, the Turing machine, the early computer, is thinking. In the case of the Turing machine, it has a scanner, and ones or zeros on a tape are presented to the scanner, and then on the basis of, here again, what state the computer is in and what the instructions say, it outputs some behavior. The behavior might be erase the symbol, erase the 0 and write 1, or erase the 1 and write 0. So there's an eraser on the machine as well, and a writing implement on the machine as well. Or the instruction might be go back a square or advance to the next square. Those are all overt physical behaviors. Here again, speaking metaphorically, I don't want to beg the question whether what goes on in a computer is intentional or not. So maybe when we say behavior in this kind of context, that's really just a metaphor. Searle would certainly think so, because as we've seen, behavior is intentional. We saw Foster emphasize the importance of that point as well. And so Searle might use behavior in an elliptical, indirect way in this context for what goes on in a computer, but it's not strictly speaking behavior. So when I say that, keep in mind that behavior is applied to the overt physical events in a computer. That has to be understood as elliptical. That has to be understood in scare quotes, just because I don't want to beg the question. Maybe it is behavior. I don't want to beg the question one way or the other, but let me just call your attention to that point. But just because a computer can coordinate inputs and outputs, it doesn't follow from that what is going on in the computer is thought, is thinking, is any cognitive state. That is Searle's point. Here again, it's just matching symbols on the basis of their shape. The rules in the computer table for the Chinese room are something like, if you see this shape followed by this shape, followed by this shape, then produce this shape followed by this shape. So you or I in a Chinese room, as Searle conceives of it, could do that. Might take a little bit of practice at first. Maybe if we have no familiarity at all with Chinese characters, they might look kind of the same. But with a little bit of practice, we could learn to do that. Presented with this string of symbols, find the string of symbols that matches, and output that string of symbols. Of course, any of us could do that. And of course, when we're doing that, it's just a kind of mechanical task. And of course, you can construct a computer in such a way as to do that. You can construct a computer as Turing already did in the 1940s. You can construct a computer in such a way as to match one string of symbols with another string of symbols in the computer table, and then output a certain behavior as the end of each step in the process of running the program. But here again, for Searle, that's not thinking. That's not the internal state of a machine doing that is not a mental state. The computer is not thinking. So Searle denies that computers can think. Just manipulating the symbols is not by itself enough to guarantee cognition, perception, understanding, thinking. So with respect to the scanner on the Turing machine that scans the image of the 1 or 0, for example, Searle would say that is not perception. That's just a mechanical process that is accompanied by no mental state, that is accompanied by no consciousness. And we've seen what Turing thought of that objection, but in any case, let's take a look at it from the other point of view now, from the point of view of the critic of functionalism. Searle says that since computers are symbol manipulating devices, merely naming the computer program is not enough to guarantee cognition. So the manipulation of symbols is a purely mechanical process. And here again, just as man in the Chinese room doesn't understand any Chinese in virtue of manipulating the symbols, similarly, by way of analogy, Searle argues that the computer does not simply in virtue of manipulating symbols think. The internal states of a computer, when that is going on, they do not rise to the level of cognition. It's not thinking, it's a purely mechanical process. And there's a lot more involved in our use of language than simply manipulating symbols on the basis of their shape, or in the case of spoken language, on the basis of their sound. Obviously, people were using language for a long time before there was any writing, but sounds are a certain sequence of symbols as well. Certain sounds, of course, stand for certain things in the world. In the case of spoken language, just as physical shapes stand for certain things in the world in the case of written language. But in either case, the sounds mean something to us. The shapes mean something to us. The shapes don't mean anything to a computer. It's not the same thing. Searle draws a distinction between syntax on the one hand and semantics. So this is very important to his critique of functionalism. A computer program has syntax but no semantics, Searle says. A program is formal. It manipulates symbols without any reference to their meaning. So what are syntax rules? Syntax rules are rules in any language, whether it's a natural language like English, or a formal language, an artificial language like math, the language of any formal branch of math, or logic, or computer languages. These are all artificial languages. These are all languages that human beings devised. And when we write computer code, or when we're doing math, or when we're doing logic, there are always syntax rules in place. And in the case of artificial languages, of course, we lay down the syntax rules at the beginning, which is different from how syntax rules emerged in natural languages. They just kind of emerged over time in natural languages, and of course they're different from one natural language to another. Well, I mean, for that matter, of course they're different from one artificial language to another as well. But my point here is that the syntax rules just kind of emerged over time as a consequence of conventions, as a consequence of just everyday usage in this or that natural language, which is a little bit different from when we consciously decide to sit down and write computer code or devise a computer language. In that case, we're deciding at the outset in a strict, rigorous, formal way what the syntax rules will be. In the case of natural languages, it's a somewhat more flexible process, isn't it? Syntax rules kind of took shape over time in the history of every natural language. They weren't kind of laid down at the outset. People just started speaking, just started talking, and over time, in the case of a natural language, grammarians kind of lay down, but on the basis of observing usage, kind of lay down what are the rules. So it's a little bit different in the case of writing computer code, where devising a computer language, where one decides at the outset what the rules of combination are going to be. So syntax rules are just rules for putting symbols in order. So these kinds of rules would be syntax rules, right? If you see this shape followed by this shape followed by this shape, then produce this shape followed by this shape. Those would be syntax rules, right? Rules for just putting symbols in order. So a string of symbols, something like cat, mat, on, the, is. Right, that sequence of symbols would not be a sentence in the English language. But of course you could write a computer program for taking that sequence of symbols, applying the syntax rules of the English language, and then outputting an English sentence, right? So that's what is meant by syntax rules here. Something like, here again, when presented, a human being, when presented with symbols such as cat, mat, the, on, is, told to apply English language syntax rules would understand to order those symbols as the cat is on the mat. So because English, our natural language, every natural language has syntax rules. So we understand what sequences of symbols, what combinations of symbols are well-formed formulas, so to speak, in our natural language. And here again, this is something that we just internalize through practice. If most of us had to explain the syntax rules, right, a lot of us would be hard-pressed to do that exactly, but we know how. But we know how to do it. And all that a computer is doing is really just mimicking, according to Searle here again, all that it's doing is just mimicking that process that goes on in us, namely that process of applying syntax rules to a series of symbols in such a way as to output something that, here again, once it is outputted, mimics language use, mimics the knowing of a language. So if you interact with a chatbot on a computer or interact with a chatbot online, right, you can present the chatbot kind of AI program with some string of symbols like what is your favorite color, and of course the program is capable of outputting a string of symbols that imitates or mimics conversation, language use, doesn't it? So the chatbot might output something like my favorite color is blue or something like that. When it's doing that, it's just matching certain strings of symbols presented as input to other strings of symbols as output on the basis of syntax rules and a program for choosing among well-formed formulas. Here again, choosing, that suggests a kind of mental state, so I'm using that in an elliptical sense, but not to get too far into the weeds of writing computer code and how this gets done. Generating, let's say, outputs of symbols when presented with certain other sequences of symbols as input. As we all know, this can be done in such a way in a computer program as to mimic, as to imitate speech. And some of these programs, in the case of computers, in the case of something like a chatbot, some of these programs are very sophisticated. They do a very good job of mimicking speech, to the extent that with respect to Turing's imitation game, it sometimes can be hard to say whether your interlocutor on the other side of the conversation online, it would be hard to say for sure whether it's another human being or an AI program. In the case of the really sophisticated, really good ones anyway, it could be hard to make that call. Which here again, as we saw for Turing, is a reason to say that what is going on the other side of the conversation, even if it's just a computer, does involve thinking. But as we see, Searle denies that. What is going on is just a program manipulating symbols on the basis of their formal shape. So when chatbot outputs to you, my favorite color is blue, that sequence of symbols, what Searle would say about that is that those symbols don't mean anything to the program. Those symbols don't mean anything to the computer. That's why it's not speech. again, a computer only has syntax, not semantics. By the way, here again, syntax has to do with the rules for putting symbols in order. Semantics, by way of contrast, has to do with what the symbols mean. And semantics has to do with meaning. The semantic value of a symbol is the meaning of the symbol. But Searle's point is that computers have no semantics. A computer program has syntax, but no semantics. A program is formal. It manipulates symbols without any reference to their meaning. So when chatbot outputs to you something like the string of symbols, my favorite color is blue, none of those symbols mean anything to the chatbot. None of those symbols mean anything to the computer program. Those symbols don't mean anything to the computer. Which is to say, among other things, that the behavior, so to speak, the activity of the computer is not intentional. Which is to say, there's no thinking behind it. There's no cognition behind it. Here again, in connection with our look at John Foster's defense of dualism, we've seen how important this notion of intentionality is in philosophy of mind. This notion that there is thinking going on behind the behavior. We saw Foster say that's what determines the correct description of the behavior, right? Is someone writing the alphabet or drawing it? You know English, so if you're writing the English alphabet, then if you're, let me put it in a neutral way here, if you're making marks on a piece of paper or on a board that are the English alphabet, you are writing the English alphabet. Because there's a certain intention behind that overt physical behavior. Man in the Chinese room, on the other hand, is not writing Chinese. Man in the Chinese room is drawing. Well, not an alphabet in this case, because Chinese doesn't have an alphabet, but you take my point. Man in the Chinese room is drawing characters. He's not writing characters. He's drawing characters simply on the basis of their shape. And that is a purely mechanical process, and that's why we've been able to devise computers. That's why we've been able to devise computer programs that can do that. Because all the computer has to do is, here again, apply syntax rules. Match the characters, match the symbols. In the case of Chinese, the symbol would just be individual characters. In the case of English, obviously, the symbols would be strings of sequences of letters, but something like the sequence of letters CAT, that string of symbols has a certain semantic value in our language, just as a Chinese character has a certain semantic value, a certain meaning in the Chinese language. But in either case, whether you're writing the symbols or drawing them depends on, as we saw Foster say, well, it was my example actually, but we saw in Foster the importance of the intentionality behind behavior. Human behavior is intentional. This is a very important notion in philosophy of mind. Well, what Searle is saying in so many words is that what goes on in a computer is not intentional. There isn't any meaning behind the behavior, so to speak. Human thought is intentional. Searle says that thoughts, perceptions, understandings, and so forth have mental content. By virtue of their content, they can be about objects and states of affairs in the world. But linguistic understanding requires a semantic framework. So Searle's point is that with respect to the manipulation of symbols going on in a computer, those symbols are not about anything in the world. When chatbot outputs, my favorite color is blue, that string of symbols, B-L-U-E, that string of symbols does not stand for anything in the world to the computer. Doesn't represent anything in the world to the computer. But linguistic understanding requires a semantic framework. No computer is understanding a language. You and I, in using a language or in learning a language, understand. This is what is in part what is meant by intentionality. Intentionality in philosophy of mind is sometimes called aboutness. It's this phenomenon of human minds that our mental states stand for, represent things in the world. So the symbols CAT to us stand for a certain kind of thing in the world. And linguistic understanding, Searle says, requires a semantic framework. It's part of our semantic framework that string of symbols, CAT, makes you think of, makes you picture, makes you imagine a certain kind of mammal in the world. Nothing like that goes on in the computer, according to Searle. The symbols here, again, don't refer to anything in the world for the AI system, for the computer. The computer, the AI system, is just manipulating the symbols on the basis of their shape. There's no intention behind, there's no intentionality behind that activity. Here again, the string of symbols CAT does not mean anything to the computer. The computer knows when presented with output some string of... Here again, when I say knows, it's hard not to fall into this kind of intentional language, right? We do it all the time. But we don't want to beg the question here. We've got to be careful about the way that we speak about this, right? If we're not going to beg the question one way or the other with respect to either side. So here again, just keep in mind when I say knows here, that should be understood as in scare quotes. I'm using the term, what I mean by putting it in scare quotes, putting it in finger quotes, air quotes, whatever you want to call it, is that I'm using the term, but I'm not endorsing it. I'm using the term, but I'm not saying that that is the correct understanding of what is going on. So, having said that, the computer knows how to match the string of symbols, where is the cat, something like that, as input with the string of symbols, the cat is on the mat, as output. But here again, that string of symbols, CAT, doesn't mean anything to the computer. There's no intentionality behind that behavior. There's no intentionality behind that activity of the computer. That physical process is really all that it is, according to Searle, in the computer. The string of symbols CAT doesn't stand for anything in the world for the computer. It does for us. We have a semantic framework. There's more to language than just syntax. There's semantics. There's what Searle is calling here a semantic framework. The kind of framework according to which symbols refer to the kinds of things in the world that they do, which makes understanding possible. But syntax by itself can't give rise to understanding. Only the combination of syntax and semantics can give rise to understanding. Thought cannot be reduced to the application of syntax rules. There's more going on in human language use than just applying syntax rules, than just combining symbols in a certain order according to a certain set of rules. So what the human brain is doing is far more than what goes on in a computer program, according to Searle. Thought cannot be reduced to the application of syntax rules. Here again, in so many words, that's what the functionalist is saying. We saw Turing saying in so many words that that's all that thinking is. It's just the application of rules for combining symbols. Human thought has content, what we saw Searle call mental content. It has intrinsic content, or here again, semantic content is a term that is sometimes used for this. We don't just combine symbols into certain sequences. There's more to human language use than that, than the application of syntax rules. We're combining them on the basis of their content, on the basis of what they mean, on the basis of what we understand them as. The intentionality, again, as I've said a moment ago, this is a commonly used term in philosophy of mind. And the sense of it here again has to do with the fact that our mental states are about states of affairs in the world, or about things in the world. So intentionality is sometimes called aboutness in philosophy of mind. It's more than just the notion, the kind of narrow notion. When you think of that word intentionality, you think of behavior. Intentional behavior is contrasted with unintentional behavior, something like that. But the sense of intentionality in philosophy of mind is a little bit different from that, although in some contexts it has that meaning as well. But it also has this broader meaning of just the aboutness of our mental states. The fact that our mental states refer to states of affairs in the world. Our mental states refer to things in the world. Here again, the mental state that you're in when you're seeing the symbol ZAT, the mental state that you're in has intentionality. Those symbols mean something to you. They refer to something in the world, to you. Here again, for Searle, according to Searle, not for a computer, but to you, yes. So this is sometimes said to be, intentionality is sometimes said to be one of the marks of the mental, one of the distinguishing features of the mental. Intentionality is one of the marks of the mental. It's distinctive to mental states that they can refer to something external to themselves. This is one of the marks of the mental. And you don't really see that anywhere else. This appears to be unique to the mental. The mental state that you're in might refer to the color of the sky. The mental state that you're in might be about a particular mammal in the world. Our mental states are about the world. And there isn't anything else that's quite like that, is there? I mean, the wall can't be about the chair, can it? The desk can't be about the pen. It would make no sense to speak that way in terms of anything really other than mental states. You could say signs. A sign for an airport is in some sense about the airport, but of course that's an example of something that that's an example of a convention that human beings with intentionality, construct to do precisely that, to refer to something else. So that doesn't really count, does it? A sign is something created by something, namely a human being, that has mental states, that has this capacity for intentionality and this ability to make symbols stand for other things. So far as we can see, it's unique to human beings. Maybe very advanced animals, primates, of course, have learned a certain amount of sign language. Of course, a dog understands what you're referring to when you utter certain sounds. But with the possible exception of some of the more cognitively advanced, developed mammals like primates or dogs, aside from those few cases, it's pretty much limited to us. This is one of the marks of the mental. One of the distinguishing characteristics of mental states. They are able to refer to other things. So, for example, my aunt has a dog that likes to bark at the pizza delivery guy. All she has to say is, "Pizza man," and the dog will run to the door and start barking. So the dog understands that that sound stands for something in the world. So this phenomenon of intentionality, we see it in the psychological states, the mental states of some animals as well. But aside from human beings and a few animals, it appears to be unique to the kinds of beings that we are. This capacity to make symbols, whether sounds or written symbols, stand for things in the world. A computer can't do that, according to Searle. Here again, a computer is just a machine for manipulating symbols on the basis of their formal properties, on the basis of their shape, in so many words. The shapes don't mean anything to the computer. Symbols and programs, Searle says, have no essential physical properties and can be implemented in any physical medium whatsoever. The zeros and ones, qua symbols, have no essential physical properties, and a fortiori, that is to say, so much more so is it the case, that they have no physical causal properties. So it's not as if the symbols are causing the machine to think, according to Searle. This zeros and ones could have just been some other symbol as well. It's not as if there's here again, any intrinsic meaning to be associated with that symbol. Searle writes, it's tempting to identify computers with some specific technology and to think that the issues are about the physics of silicon chips. So what is he driving at here? Some proponents of strong AI might concede that computers aren't thinking yet, but they might say something like, well, at the point where the technology is far enough advanced, it will be able to do everything that a human brain does, and at that point there's no reason for denying that the computer is thinking. But Searle doesn't believe that. He denies that. He disagrees. It doesn't really matter how the technology changes, according to Searle. That's never going to matter. It's still just going to be the manipulation of symbols on the basis of their formal properties. It doesn't matter what kind of hardware that activity is implemented in. There's always going to be a difference between the brain and anything artificial, according to Searle. He thinks the brain is unique. It has causal powers to bring about this phenomenon of the mental that nothing artificial ever will. He says one could, in principle, make a computer out of old beer cans strung together with wires and powered by windmills. Here again, if you could come up with something like that here again mimics speech, then in principle there's no difference between that and your computer. It's just here again some machine for manipulating symbols. So it doesn't really matter what the technology is. According to Searle, it doesn't matter how far it advances. If it advances beyond silicon chips to some more powerful hardware for computing, it's not going to matter, according to Searle. It's still just the manipulation of symbols on the basis of their shape. The symbols still don't mean anything to the artificial thing. So we've seen that according to proponents of functionalist theories of mind, the mental is plastic. That is to say, it can be realized, it can be instantiated in any number of physical arrangements. A brain, yes, but also artificial arrangements, computers, artificial intelligence systems. The mental is plastic. It can be, according to proponents of the functionalist theory of mind, the mental is plastic. Searle denies that. Searle denies that the mental is plastic. He does not think it can be realized in just any physical substrate, just any physical basis. He thinks it's something unique to the brain of human beings, and here again, to some extent, the brains of other advanced mammals as well. There's something unique about the causal powers of an advanced brain that nothing artificial can ever duplicate. So perhaps it's only computation that is plastic. Here again, computation just understood as the mechanical task of matching certain outputs of symbols to certain inputs of symbols. That might be plastic. So Searle acknowledges that computers and so forth, calculators, even going back to this very old calculation machine, the Babbage machine, 19th century, British early version of the calculator, obviously bulkier than calculator. There are any number of mechanical ways now that computation has been instantiated in man-made and artificial entities. The Babbage machine, the primitive kinds of calculators, the Turing machine, more advanced computers. Maybe computation is plastic. Computational processes, Searle says, are completely independent of any reference to a specific type of hardware implementation. So maybe computation is plastic. Yeah, maybe that can be realized in anything. And maybe as the technology advances, the computational powers of computers will continue to advance dramatically as they have in our own times, but it's still not going to rise to the level of thinking, according to Searle, because the mental is not plastic. The mental more generally, the intentionality of our mental states, that is not plastic. Searle thinks that that is unique. It's something unique to very highly developed brains. The plasticity to computation may not hold for the mental more generally because of what Searle calls the extreme specificity of the brain's causal processes. Although science is largely ignorant of how brains function to produce mental states, Searle writes, one is struck by the extreme specificity of the anatomy and physiology. Thirst, for example, he says, is caused by certain types of neuron firings in the hypothalamus, which in turn are caused by the action of a specific peptide, angiotensin II. So this extreme specificity by which biological processes, biochemical processes in the brain, cause mental states, it's so extremely specific at such a low level of physical components as peptides, right? And it's so specific to those very low level particular kinds of bodies or biochemical phenomena that he just finds it implausible. He's just skeptical that anything artificial will ever duplicate those kinds of causal powers. Causation is, Searle writes, from the bottom up, in the sense that lower level neuronal processes cause higher level mental phenomena. So that also sounds a little bit like what we described as the epiphenomenalist view, right? The epiphenomenalist says causation is only one way, from the brain to the mind. Now, again, the epiphenomenalist view is that they're not just the same thing. Mental states are distinct from brain states. But the epiphenomenalist agrees that brain states cause mental states. And Searle, in these selections, always puts it in terms of the brain state causing the mental state. He never puts it in terms of identifying the mental state with the brain state. So that's why he sounds to me, at least at times, closer to an epiphenomenalist view than an identity theorist, an identity view. But there are different permutations. There are different kinds of versions of identity theory that you can get into. That to get into that would take us a little too far afield from the main topic of the moment. And Searle's a very original thinker. So it may be some view kind of in between an identity theory like Smart's and functionalism. In any case, suffice it to say that he does not believe that anything artificial, any computer, any kind of AI system could ever have this kind of causation, this bottom-up causation that we see from brain to mind, such that it could duplicate what is in us a mental state. Computers will never have that kind of power, according to Searle. And it doesn't, as we've seen, it doesn't matter what the hardware is. It doesn't matter how far the technology advances. None of that matters, according to Searle. It's still just going to be the manipulation of symbols on the basis of their shape. And that still is just syntax, not semantics. So this is one reason why Searle is such a provocative philosopher. That kind of has been his style over the years, is to be provocative. Some theorists of mine are more cautious. They say, you know, I'm kind of doubtful that a computer will ever be able to think. Searle just comes right out and says it. No, it won't happen, and I will tell you why. Here's exactly why it can't happen. No matter how far the technology advances, it's just going to be the manipulation of formal symbols on the basis of their shape. The symbols don't mean anything to an artificial system. They have no semantic content, and they never will. It's something tied to the extreme specificity of the ways in which a brain causes mental states, and that will never be duplicated by anything artificial. As far as we know, Searle writes, every mental event, from feelings of thirst to thoughts of mathematical theorems and memories of childhood, is caused by specific neurons firing in specific neural architecture. So, again, there's an extreme specificity to the ways in which the brain causes mental states. And nothing artificial can duplicate those kinds of causal powers, according to Searle. Why should this extreme specificity matter? Searle writes, the brain does not merely instantiate a formal pattern or program. It causes mental events by virtue of specific neurobiological processes. Brains are specific biological organs, and their specific biochemical properties enable them to cause consciousness and other sorts of mental phenomena. So again, he has no problem with what we saw him call weak AI. Computer models are useful for studying the mind, but a computer simulation is never going to be the real thing. Just as a computer simulation of what happens in your metabolism is never going to actually break up any food and give you some energy, right? Or just as a computer simulation of a storm is not actually going to get anything wet. Similarly, a computer simulation of what goes on in thought is never going to have the same causal powers as thinking. That's why the extreme specificity of the way that a specific biological organ with specific biochemical properties causes mental states, that's why it matters. Anything else is just a simulation, not a duplication. There is no good reason to suppose that a computer simulation of brain processes would ever have the causal power of the actual processes themselves. So, according to Searle, thought is, or at least it's tied in a very intimate way to specific neurobiological processes, specific biochemical processes in a brain. In our selections, Searle refers to what Turing called the moving the goalposts objection to his theory of mind, or to functionalist theories of mind. What we said in the context of Turing's writing was sometimes called machine functionalism. So we saw in our selections from Turing that Turing says, this question, can computers think? We're just going round and round. We're not really making any headway. We're not really making any progress with respect to this question. Let's replace that abstract question with a specific testable hypothesis. If a computer can succeed at the imitation game as often as a human player, then it has to be thinking. And so Turing's critics would come back, well, but a computer can't be conscious. Well, but a computer can't have emotions. Well, but a computer can't invent anything new. Turing characterized so many of these objections as moving the goalposts on him. That is to say, he would come up with some specific testable hypothesis, show that a computer can do it, and then his critics would always say, well, but a computer can't do this. Well, but a computer can't do that. Well, but we can think of questions that a computer couldn't answer. A computer can't invent anything new. Turing's frustration was expressed by calling so many of these objections just moving the goalposts on him. That is to say, so to speak, metaphorically speaking, he scores a touchdown, and then the opponent says, oh, no, the goal line wasn't there. The goal line is 10 yards further down there. You have to cross that goal line before we'll say that a computer is thinking. So Turing was impatient with these kinds of objections, and he complained that his critics were always moving the goalposts on him. Searle's reaction to that criticism of Turing's is that in so many words, no, that's not what I'm doing at all. I'm not saying that you haven't got all the way to the goalpost yet. What I'm saying is that we're not even talking about the same thing. Searle says the point is not that the computer gets only to the 40-yard line and not all the way to the goal line. The computer doesn't even get started. It is not playing that game. So Searle would say, in reply to Turing, he would say that they're not talking about the same thing. He's not moving the goal line. He's not moving the goal line on the functionalist. He's saying something quite different. He's saying that the functionalist and he himself are not talking about the same thing. Because the functionalist thinks that, here again, simply instantiating a computer program is thinking. Simply running a program is thinking, is cognitive activity. Simply manipulating symbols on the basis of their shape is all that thinking is. Searle denies that, as we've seen. That's not thinking. So it doesn't matter how advanced, it doesn't matter how advanced the mimicry can become. It doesn't matter how realistic, how advanced the simulation of human behavior in something artificial. It doesn't matter how advanced it becomes or how sophisticated or how highly developed it becomes. It still is not going to be thinking. That is Searle's view.